Welcome to the talk on digital identity in Industry 4.0. My name is Martin Sandren, and I will talk to you a little bit about our experiences in this space and what we believe where the industry is heading and how you can apply digital identity within Industry 4.0. So the agenda for today consists of 4 points. We're going to talk about the IT and OT cultural gap, why it's different. We're going to talk about something called the TCP/IP moment for IM, role of industry or of IM in Industry 4.0, as well as what does it mean for Nixu, for our clients. So the IT and OT culture gap. So how many of you have seen presentations before that discusses this? Hands up for. Okay, good. That's at least a few people who hasn't seen it, so it's adding value. So these are 2 photos. One is of me and my kids when we moved to the Netherlands. It's taken in Vondelpark. The other is of how my neighbor takes her kid to school. And as you see, there's something strange with the photo of me and my kids. And can anyone say what's strange with this? Oh, that's one thing, of course. In Amsterdam, normally you have to wear a coat. But it was one of the nice weather days in May. There's something else. The helmet, yes. So before I moved to Netherlands, I lived in the US, and I'm originally from Sweden. And in Sweden and the US, you wear helmets when you bike. In the Netherlands, you don't. So when we moved to Amsterdam, we put the kids into the local preschool. And after like 3 months, I was chatting with one of the other parents. And I was talking, we moved from the US, and I said, yes, you're the helmet family. Because we were the only ones that had helmets on. And the Dutch approach to this is, you put your kid on top of your bike, and then you just bike around. The interesting part is that there's not more fatalities on bikes for kids in the Netherlands compared to US based on usage of bikes. It's that the system is completely different. That the entire traffic system in the Netherlands, especially if you come to like Amsterdam and similar cities, is built around bikes. So there's bike lanes everywhere, and the cars is always liable if they run into the bike, no matter what the car did. If they stand still, they're still going to be 25% liable if they have an accident with a bike. So on one hand, you see the approach of building in safety and security by putting the kids in a helmet and strapping them down, and there's actually a steel box that's a back feet that the kids are in a cargo bike. The other approach is to change the system around, and then you don't have to put the helmet on the kids. You get the same net effect in both systems. So this picture is from one of our large manufacturing and logistics clients. And there's 2 things in this photo that will tell you where the company is really from. The photo is taken in Brussels, in Belgium. So can anyone guess what will tell you about where they are from? Well, the first clue is, of course, the Japanese signs there. I'm not entirely sure what it says. It's clearly something much larger because there are Chinese signs as well, so it's probably a very, very polite way of telling you to grab the handle. But there's one more thing in this picture. So if you look at the arrows, it's left-hand traffic. So in that building, they are using Japanese-style traffic, so you go on the left instead of the right. The interesting part is that you will see these, if you go to a company whose core business is manufacturing, you will see these signs on all stairs, even in the office. As soon as there's more than 3 steps, there has to be a handrail and you have to use it, because otherwise you can have an industrial accident. This is even worse if you, for example, go to Shell. So in my previous life, I worked for a company who did a lot of Shell work, and you could look at the consultants that came in their suits. If they were at the Shell account, they would have this kind of reaction that if there was a handrail, they would always grab it, because that is how you're trained. And this is a big difference between IT and OT, that safety is very paramount in OT. So let's talk about the main differences. So one difference is that in IT, a system lasts for at least 3 years, 5 years in most cases. If it lasts for 10 years, then it's a very old system. In OT, you can have a system that runs for 20 years or 40 years. I've seen some implementations. For example, we had a large implementation as one of our manufacturing clients that lasted for 7 years. So obviously, then the lifetime has to be a bit longer. OT systems, either because they're old or just because of limitations about available power and similar things, may not have the same processing capacity or memory or even bandwidth available. And reliability and availability are really, really critical in manufacturing systems. So what this means is that applications updates may no longer be possible because the people who wrote it are long gone. They might even not be alive anymore. Many OT systems do not support modern protocol because 20 years ago the modern protocol didn't exist. And security measures, if you're used to it in the IT space, you're used to that, you can essentially usually patch in the night unless you have a system that supports a lot of very different time zones. And you can definitely patch in the weekends. Well, in an OT setup, you might only be able to patch once a year because that is the time when they shut down the system for maintenance. Otherwise, it runs 24/7. So next to this move into the cultural difference between OT and IT, we can also see a big change in the IAM space. And one word for this is the TCP/IP moment of IAM. So this gentleman is Ian Glacier. He's one of the luminaries in this space, and he used to work for Burton Group and then Gartner, and the last, I think it's 4 or 5 years now, he has been doing the IAM part for Salesforce. And one of his big things is that he believes that the IAM space will go the same way as networking space. So for you that has been in IT for a while, perhaps like me back into the 90s, back then it wasn't self-evident that if you bought a network card and a router or a switch, switches were expensive, but that if they were from different manufacturers, they actually would work. If you look at the wireless networks, you had to buy the wireless network cards and the net radio stations from the same manufacturer because there were no standards. And then the standards came, and today, of course, network card from Cisco and from some no-name manufacturer will be able to talk to a router from Cisco. No one expects that, anything else. So the belief, this quote is from 2015 from EIC, and obviously it's taken a while, but it's really happening. We are seeing that the protocols that have been put into the industry over the last few years, they're actually being adopted. And that's because they are well defined enough and they are simple enough to actually implement correctly. The protocols, before we didn't have any protocols, or the protocols were so complex that most people didn't manage to implement them. You couldn't do the business case for implementing them. So what does that mean for the IAM space? Well, you essentially have a change in way of doing things. So this picture is from the summer, and it's my kids in the red, a little bit bigger now, and their second cousins. So my kids have an American mom and a Swedish dad and grew up in Netherlands. So they speak English as their first language, Dutch as what they learned at school, and I have managed to teach them decent Swedish. Yeah. Their green cousins there, they have Swedish parents, but they're growing up in Luxembourg. So they have Swedish as their primary language. They speak German and French in school. They speak Luxembourgish, which is a kind of a hybrid between German and French, as with their friends. They learn some English from YouTube and also as their third language in school. And the blue ones have Swedish parents and grew up in Sweden, so they speak Swedish and some English. And it used to be that, if the red was Oracle and the green was, for example, Microsoft and blue was IBM, you can't have these people talking to each other. But just like when we put them together and said, hey, this is an amusement park in Gothenburg, go out and play and go to whatever you want to ride, they just happily self-organized and started talking, and they negotiated which language they're going to speak together. And it just worked. And this is the big difference, that previously, if you have from a different manufacturer, you could get it working. We, for example, have an integration between an IBM stack and an Oracle stack at one of our big retail clients, but it took a lot of time, a lot of effort. Now, well, we just do a SAML integration, and it works. So again, then we go to the next layer in the Russian doll. What does that mean for us as a corporation and for our clients? Well, one of the first identity implementation I did was back in 2003 between two ERP systems. And we spent 100 days doing this. And it was still considered a success because the business driver was so strong that you could actually amortize the cost. It was okay. Essentially doing the same thing if you go then forward about 10 years when SAML started being supported in different places. I used to be able to charge 50 days from my client. So I ran a quite large team. We were like 15 people on the development side and another 8 or so on the maintenance side. And we could charge 50 days for a SAML integration. And we did burn the time because you had to negotiate the details, which attribute do you encrypt, which one do you sign, and then you tested it, and then it was whitelisting of IP whitelisting of different hosts. But fundamentally, you could get the 50 days of the client. Now, if you look at the standard SAML, you basically get the information about which is the endpoint. You just plug it in and get the certificate from the other side, the XML export. And you can perhaps charge 5 days in an enterprise for it. Most of that time is essentially going to the change board and so on. What we're also seeing is that a lot of application comes pre-integrated. The only thing you need then is the information about what is your name of your tenant on the SaaS solution. How are you allowed, it's a password or a identity, a key, and you just plug that in, and then you press the button, and then it works. And because you don't do this low-level stuff that you have to do on the standard SAML integration, you have a much lower chance of blowing the entire system up. With standard SAML, you usually can, if you do it wrong, you change in the policies, and then suddenly something in that corner stops working. And that means that the amount of change boards and similar is also much lower. It's just a service request. So what you see here is that the amount of effort that we can charge our clients is going down. But obviously, it's because the amount of effort it takes to build this is going down. So the clients are expecting the cost and the friction per interaction is much, much lower. So that being said, we now know what the differences in the culture. We know a little bit about what's happening on the OT side in IAM generally. What does that mean for Industry 4.0 and IAM? Well, let's just quickly talk about what Industry 4.0 is. I started looking into this and discovered that there's a lot of different opinions about this, but this is one definition. So you have the 4 different industrial revolutions. First steam, then came the combustion engines in the telephone, electricity. Then after the war, you had the robots, the computer systems, and then internet. And right now, we're in the automation interconnection age. And basically what you see here is that you also have a movement from something. Before steam, you had to build your factory at a place where you had a fast-running stream for power. With steam, you could build it essentially anywhere where you could get coal to, and the other raw materials. And if you look at the fourth revolution, it's about lowering the cost of interaction, that instead of having a centralized system, you have interconnection between peers. You share information between different parts of the manufacturing process. You share not only information, but also the metadata, so it becomes understandable. You have technical assistance that the engineers who work the systems, they get help, they get virtual reality or augmented reality, and they can get information from the devices. You have a decentralized decision. Previously, every information went up the chain to central, and the decisions went down. now you have a peer-to-peer decision mechanism. So what does that mean from, if you look at, for example, logistics as an example? Well, this is for distribution centers for retailing for food, but essentially the same approach and same idea can be found in everywhere. So back in the 80s, my mom used to work in a distribution center in Sweden. And her job was to take the written orders from the stores and type it into a mainframe. And then that went into the mainframe calculated what should go into the next truck was coming in a few days or a week's time to the same store and make sure that they get replenishment. So that was what she did. She typed information from paper into a mainframe. And obviously the IM needs of this kind of setup was quite low. You needed a few mainframe accounts for people like my mom and perhaps for the admins of the system, but nothing else really. My day-to-day job, my main client is a very large retailer, a global retailer, and my team in the IM have been outsourced to the local distribution center. So it's us and the mostly Polish truck drivers and task workers who fill the trucks. So all the signs in my workplace is in Polish, so it adds a little bit of a challenge sometimes. Here you can see a revolution in productivity. So you have a similar amount of people, but it's serving almost a factor 10 more customers from the same sized distribution center. The IM needs have become larger because now everyone needs an IM account because the task workers they want to see how much money they get at the end of the month, they want to see which shifts they're on, they need to do trainings and so on. Right next to that, there's a new distribution center being built, which is a fully mechanized distribution center. And here instead, basically robots do almost everything, from the trucks coming in with the pallets to the trucks going out to the individual store with exactly what that store needs. And now instead of having one delivery every week, many of the stores don't have any storage at all. So essentially they have what is on the shelf. So they need to be replenished several times per day. And if they don't, there's no food on the shelves. And now it's staffed by 50 robot engineers who will maintain these robots, and about 50 task workers that do some manual stuff. Is there anyone who can guess what is the hardest thing to automate? What is the product category that we have not figured out how to automate yet? Huh? No guesses? It's actually toilet paper, because it's squishy, so it's very hard for a robot to grab it properly. So that is still being manually handled. So here you see the kind of the travel that we take and the increase of IM need as we get into more and more modern systems. So how did we use to build this? Well, we used to build, when we came into a factory, was that the factory was its own little island. We air-gapped it. Initially, this was very easy because the protocols didn't route. So, if you have an analog system, obviously you have point-to-point. If you have a field bus, it still is something that's very local. And that works fine until you wanted to start communicating with the entities in the factory. So as more and more things needed to communicate, the first thing we did was that we put everything into contact with an ERP system. And that ERP system then communicated through SFTP or equivalent. And again, this worked fine also from a security perspective. Everything is very isolated. You can put a network, you can put a firewall, and it will actually isolate the factory without a problem. Now, more and more devices want to talk to other things. So this approach is working less and less well. So the initial part is the ERP to ERP federations. So you have the factory 1, you have factory 2, and you have your users. They all work against the information in the ERP. And the information exchange is going through ETL, SFTP, or similar. So the first part when we start talking about IAM here is that the ERP users of Factory 1 sometimes need to see what's happening in the Factory 2, because there might be different components in the supply chain. So we put in a SSO. One example of this was also the same I showed on the effort side initially. This is for fighter jet maintenance. So you have one team of people whose job is to keep these fighter jets in the air, have a high availability as possible on them. Usually with fighter jets you have an availability of 25%. So 75% of the time they spend being maintained and 25% they could actually fly. And you have a lot of spare parts and very expensive spare parts. And if you run a global operation, you have the problem that the spare parts are also distributed globally. So the business case here was to try to make it possible to see what was happening in the manufacturing system. So what spare parts were sitting in the manufacturing system or going to be available soon in the manufacturing system. And if we could cut down the amount of spare parts that we need to keep in the maintenance system, let's say you had 100 million euros worth of spare parts in the system. If you could cut down that with 30%, that's 30 million euros worth. 5% on that, it's a quite nice sum. So we built ERP integrations so that the maintenance users could easily log into the SAP system, manage the manufacturing, and basically say, there is a thingy here that I could use. So if I can put a lock on that one, then I can use the one that I have sitting on the shelf in Bahrain, and I can have the new part being shipped out to Bahrain as soon as it's ready. And I can hit my SLAs on availability with having a much smaller amount of spare parts in the system. So what you end up here with is that everything needs to communicate. Not only with the ERP central control systems or the SCADA systems or the other system that directly controls, but also out with peers, and also with the peer systems in the factory. Boston Dynamics have shown some very interesting cases where you don't have these very linear lines in factories, but you have robots that interact and work in a much more flexible and agile manner. And to do that, you need identities not only for humans, but also for the devices. So, what does this all mean for us for our customers and for us as Nixu? Well, the client expectations are changing. So our customers expect lower friction. They expect that they can take their systems and just put them together and they will be able to talk. Not that it will take 100 days of effort to have two different systems integrate. Not only in the IT space, but it's also going to be the same kind of expectation coming in OT. And they expect that the cost per integration is going down. So what does that mean for Nixu? Well, one thing is that there is now a market for identities in the industry. If you look at an industry floor, there needs to be peer-to-peer communicable identities on all the devices. We need to enable the ability for remote support of the devices. And there's of course a huge addressable market that we can look at here. It does also mean that the old cushy business model of being at a large corporation and having a team of 5, 10, 15 people sitting year in, year out doing integrations, taking in new applications onto the platform, or then a couple of years later we have to upgrade the system, so then we have to do it again. It's a very nice model, kind of like a snowball. That is becoming less and less relevant. And we also are not able to, in the same way previously there was very complex on-premise system. As they move to the cloud, the maintenance becomes much cheaper because the maintenance becomes centralized. So there's no need anymore. We had one client, for example, that went from 3 FTEs to 0.5 FTEs when they switched from an on-premise to a cloud CM system. So obviously there's a market that is disappearing and the new market shows up. one important thing to remember here is that the manufacturing is a market that's going to have a lot of legacy. So we are going to see a lot of old systems that we still need to maintain in the old way. And that's, of course, also going to be an interesting market. Was one very interesting paper released by Microsoft about BASF, big chemical company who has now moved into Azure AD as the main identity system globally within the company and the interaction that enables. Obviously, they probably have thousands or even tens of thousands of systems that have no idea what SAML is. That's still going to require old-style logins. So that there's going to be a very interesting opportunity to do all of the ping-based, old-style, header-based, or even fake logins with username and password to enable the single sign-on from the new world back to the old one. So, thank you very much for listening, and I hope that this gave you some interesting information about what we're doing for some of our major manufacturing clients.